Welcome back. This is an Aleks training video in understanding the difference between strong and weak acids. Strong acids are not more corrosive or dangerous. Strong acids just completely break apart into ions when you put it in water. So if you have something like HCl or HBr or HI, HClO3, HClO4, H2SO4 or HNO3, the 7 strong acids, then you'll never have the acid in the water. It completely breaks apart into the hydrogen plus the conjugate base. If you have a weak acid, it's not weak because it's not corrosive, because lots of weak acids are very corrosive. But instead, what it means is it doesn't completely dissociate. You're going to have some of the original acid in the water, and then some breaks apart into hydrogen plus the conjugate base. So, simple question. Just remember that they're asking for everything that's in the water. And I would assume it means the water also. Okay, so let's look at this first one. First one, HCl. They gave it to you. You should memorize these 7, but they went ahead and gave it to you. If it's not one of the 7, it's a weak acid. If it is one of the 7, it's a strong acid. So they went ahead and said HCl is strong. Instantly in your mind, you say strong. That means there is no HCl in the water. There's only the hydrogen plus the chloride plus the water. Okay, now remember, it's not just hydrogen, it's H plus, right? So you're going to say that there's hydrogen ion in the water. I assume they want a comma. They want chloride. Remember, if this is neutral, HCl, and I take a positive, I leave you with a negative. So hydrogen ion plus chloride ion, and then the leftover is the water itself. That's what's in the water. There is no HCl in the water. Okay, the next one, this is carbonic acid, H2CO3. It's a weak acid, which means it doesn't completely break apart. Okay, it doesn't completely break apart. The sum that does break apart will be the hydrogen. Okay. What is its conjugate acid? What's the conjugate acid of the hydrogen? So take one hydrogen off H2CO3. You'll see that it becomes negative. I end up with 1H, CO3, and the negative to it. Okay, so you've got the H, you've got it's broken apart. Okay. Then it's weak. So what does weak mean? It means the original is in the water. It doesn't completely break apart. So you're going to have H2CO3 in the water. What else are you going to have in the water? Water. So H2O. You'll have H2O in the water. Do you see how easy this is? I think you can breeze through these. Okay. So this is bromic acid. Bromic acid is a strong acid. So in that case, it's going to be H plus. What is its conjugate base? So take the H off, and you'll be left with BrO4. And remember, if it's neutral over here, and I take a positive, it's going to leave you with a negative. So BrO4 negative. And then that's all you have, plus the water. And now the last one. It says that the HClO2, which is hyperchlorous acid, is weak. That means that HClO2 will be in the water, but let's do the rest of it. Some of it's going to break apart into that. What's its conjugate? Its conjugate's whatever is not the H. So you look over here, whatever is not the H, and since this is neutral, it's neutral here. If I take a positive, I'm going to leave a negative. So this is going to be ClO2 negative. Now it's weak, so what does that mean? It means some of the original is going to be in the water, and then the water is in the water. Okay, pretty straightforward. I think you can do it.